Okay, let's get started. So this is a quick introduction on how do we use the rain interpolator. Uh, since I said it's quick, so let's go get into it. So first thing I usually do is just select rain values. So this rain values is typically a CSV file, and the format is station date in YYY 4-digit year, month, and day with no blanks or anything in it, and followed by rain. So there is a sample data file posted on the GitHub site, so you can check that to make sure that your data is formatted in that way. I downloaded all my data from NCDC site. That's NOAA NCDC site, and it's a good site to get precipitation data, at least for United States. So if you use that site, you can pretty easily get the data in that format. So even the raw data which you get from NCDC, once you've selected the stations you want data for, is pretty much in this format. So here we go. So go to the folder. So I have put all my data in the GitHub folder here. So here we go, and rain, and then we just click open. So what it does when you click open is load the CSV file in a H2 database. That's the embedded database engine which is on the back end doing all the fancy computations for you. So and then it spits out a data summary. So it's telling me the Alexandria 18 SVA station has 515 data points from 2000 and 2010. If we go down, the Reagan National Airport has pretty much complete record, and it has 5508. It is complete record from 2000 January 1 to 2015 January 29. So that's just a summary. Next thing you might want to do is to select the watershed shapefile. I'm using Arlington boundary, and I when I was downloading data from NCDC, I had the boundary in my mind, and I downloaded stations around Arlington. So this is Arlington, Virginia, by the way. So one thing to note about this shapefile that it needs to have a projection system. So if you need pointers on that, I have a how-to document on how to how to assemble the input data, and that will have all the information that you need. Uh, and there's another thing: the projection system should not be in decimal degrees. It's hard to compute distances from decimal degrees, and this version of rain interpolator does not do it. So you will give errors. Well, it will not give you error, but wrong numbers. So make sure your projection system is in meters, feet, miles, centimeters, inches, whatever, but not square miles, not decimal degrees. So, and this is a polygon file. So let's just open this, and you see that it said that mine was in 83 Virginia Lambert. This actually is in meters. Then the other input I need is the location for the stations. So again, this is an Informer shape file. So when I downloaded data from NCDC, I got latitude and longitude for every station, and it was fairly easy to compute to create a shape file from latitude and longitude. Again, this shape file needs a projection system. It doesn't have to be necessarily the same as the watershed boundary, and this can be in decimal degrees. Because for computation, all the other georeferenced or spatially referenced data is actually converted to the coordinate system of the watershed shapefile. So let's just open this up, and then it will give you what stations were there. If you don't see the right station names, you might want to change the column in which you have stored station name. For me, it was correct. This is very important that the station names are same as the station names you use in the CSV file with the data in it, because it's going to use that key to match data to station. If it's not, it will not work. Uh, then you have to click View Grid. So what does View Grid do once it starts up in a bit, and it's starting on a different screen, so I'm just going to bring it in here. What this does is actually shows you what data have you input. So these are your stations for which you have data, and then it also shows you, well, I guess this doesn't move, huh? It also shows you the outline of shapefile, and you see these hexagons, which are basically the grid elements where the rainfall would be computed, and then eventually it will average all the rainfall for each hexagon to compute the rainfall for the whole watershed or polygon or whatever polygon you're interested in. 50 seems a bit overkill, so I'm going to make it 20 here, and again view grid. It's essential to do view grid because when you click view grid, it shows you the grid, but when you close this thing, it's actually creating the grid on the back end. So make sure you hit view grid. Now let's go to the execution step. Number of threads is computed based on the number of processors you have. I have a 4-core machine, so that's 4 thread. Power is the IDW inverse distance waiting power. So if you want to do a Thiessen type interpolation, you might want to get the power up high to around 50, but most natural system power of 2 is pretty good. Neglect distances is automatically computed as twice the extent of the polygon of your watershed. If you don't want to use it, use -1. So -1 basically says to not use neglect distances. So all stations will be used for computing rainfall every day. Start date, end date are computed based on your data, but if you want to change it, go ahead, change it. Now, what you need to do is hit the generate daily button, and okay, that's pretty fast. So it's going to generate a daily button, a daily rainfall time series. So essentially, what it's doing is it's generating a daily rainfall time series and putting it back in a database. It's as I said earlier, it's using a H2 embedded in-memory database. So it's just putting a time series of daily rainfall in there. And once it's finished, which should be in less than 1 minute, we can go to the analysis step, and there you go. So once it's done, it's going to say finished all, cutoff distance -1 analysis step. So if you know how to use your databases, this is the JDBC URL. You can connect directly to it. It only works when this application is running. The last thing to do is save the output. So I'll call it output.csv. Save. And there you go. Done. So you will have something like, okay, I'm trying to open it. A file like this. You have date and value. So every day you will get 1 rainfall value. Again, the rainfall I had put in through was in 10th of millimeter. So this output is also in 10th of millimeter units. So just to give you a quick idea of what happened on the back end, let's go back to the grid. So what it did was compute at every day time step. It computed rainfall for each of these grids, and then averaged all the rainfalls to give you average rainfall for the watershed. So that's pretty much it. I hope it helps you. If you have any questions, shoot me an email, or oh well, the source code is on GitHub. Feel free to modify it as you want. Okay, that's pretty much it.